Yes, oh, thank you very much, David. Yeah, it's about pitfalls and challenges that will be belong to the past and soon foreseeable future. And first of all, and this will be the major part of my presentation, I would like to talk about how the upcoming revision of the ISO standard on PDF will resolve these issues. So this is the positive message right now, so you can go to the coffee break. Good. So, as David just mentioned, it all started with the release of the ECI Altona Test Suite at the technical page 2, which is also known as the kind of transparency test form. And rendering of this test page on a variety of output systems and workflow systems showed that there are some issues with in specific areas of transparency rendering. And going deeper into the details and finding the reasons, it was mainly two issues that caused the problems. On the one hand, it's bugs. Bugs will be fixed, so no reason to talk about this now. All the software engineers will know what goes wrong and what is right. So this will be not the topic to talk about, and this was nothing to discuss long about. But there were also, and this is the much more important thing, differences due to different understanding of what stands in the standard. So if one has this understanding and the other one has the other one, then the reason is that both may be right, but at the end, for the end user, it's not a good situation because there is inconsistent rendering of the very same document, which is not a good idea. So after some kind of constructive and interesting discussions between ECI and some vendors, we came to the point where it is good to sit together, have a meeting, and discuss so that a solution comes for the end users that so that we can get rid of all the problems that we have so far. So, and this meeting took place in Munich last year in July, and it was the so-called Transparency Summit. And here you see almost all of the people sitting there. The only one, Peter White, is missing because he took the picture. So there are some other people in the room, like Leonard, who was with us there, and Olaf, and some others who, like Peter and I, who we worked on the ECI test page. And the topic of that was to on one hand, find out what is wrong and what is very, very positive, to say that we had a very constructive meeting in terms of how to address the current problems, and as we saw during the discussion, to even enhance those things, those parts in the standard that cause behavior of the system which is not what the end user expects. So there are some situations that may, if properly rendered by the systems, that this behavior does not match what the expectation of the user is. I will have examples to explain this. So at the end, we came to several points that needed some changes, and the next step was then more than a year later, because some things take a while. We had an ISO meeting on PDF in Vienna this May, and there was a working group under Instant installed to write that section, that chapter 11 on transparency, so that it can be incorporated into the new release of the ISO 32000 standard. And in this new version, there will be the proposed changes from the Munich meeting, and as an update of the existing standard. And I would like to go a little in depth, explaining the 6 issues that we were discussing there, and that will be fixed then. So it's something. Some of these things are very technical, so bear with me. One thing was that, as I said, the standard was not clear enough so that every implementation did it the same way, in a consistent way. And one of the topics there is the use of transparent and opaque imaging models. So there are differences, especially if it comes to color, where the two models behave in a different way. And for that reason, it's of course good to have a consistent implementation. So today we have a mixed use of opaque and transparent imaging model. And as I said, there are different understandings. One understanding is that the transparent imaging model must be used for all objects inside a transparency group. And technically speaking, this is objects that are stored in a transparency X object. So this is one understanding. The other is that the opaque imaging model may be used if an object inside such a group is not overlapped by any transparent object. So the end user may then really expect that why should it be converted? It is like an opaque object. Why not treating it as an opaque object? Both is valid thinking, but the problem is that as a consequence, some systems may work along the transparent imaging model, which requires in some instances a color conversion, while the other approach says it's an opaque image and there may not be that color transform. And at the end you have different results, which is not a good idea. So we discussed this, and the solution is that we have now one agreed understanding, which is that the permanent use of the transparent imaging model has to be implemented, regardless of the existence of a transparency on the page. So this removes, of course, the different understanding problem, but it is also said as an implementation note that it's the outcome that counts. So there's no need to really implement it from the software standpoint, as long as the final result matches what would come out from the transparent imaging model. So it's up to the user, up to the engineers to take the path they wish, as long as there's a consistent result. So this was one of the critical things. Another one that caused problems or differences between the expected result of the Altona Test Suite technical page 2 and the rendering is the question coming to the standard, whether is the wording color conversion to the blending color if blending color space if necessary. So what means is necessary, if necessary? So there was different understanding of this. So in today's implementations, and it's getting more and more consistent, but at that time last year we had the situation that one understanding was that a color conversion is necessary for all objects in a transparency group having a color space and or color characterization which differs from the transparency group blending color space. So those of you who are not familiar with it will say, okay, good. Just imagine you have a blending space with which is RGB, and you have an object inside of this transparency group which is cmyk. Then this cmyk object prior to rendering of the transparency result has to be converted. So this is the reason for the color conversion. For you have for the rendering the need to have everything in a consistent color space. So this is the understanding A. And the other one is a color conversion is not necessary if such an object happens to have the same color space as the blending color space. Say, to bring it down to the examples where it may differ, gray is gray, but ICC-based gray, so gray with a profile, is not the same as a device gray. The colorants are identical, it's just gray, but they are different. So here, according to this understanding, there may be some color, there would be color conversion, while in the other understanding it is not. Both is gray, so why convert the gray object? So with this in mind, you can imagine that also in other cases there may some color conversions occur or not, which has some impact on the final result of the intended graphic design appearance or so. So the solution here is
Can you go back one? What's the difference between A and B? For me, it's the same.
You have the color space plus the color characterization. The color space in both cases is gray.
And not from the phrasing of the sentence. I think the text is wrong.
What do you mean?
In A you say a color conversion is necessary if the colors differ from the blending space, and in B you say the color conversion is not necessary if the color is the same.
it's about the color space only here. And here it's both.
Yeah, but
it's,
you need to
Okay.
reformulate this sentence, I think.
Stefan, those are just, that's just part of the slides, it's not the wording from the standard.
Yeah, I know. That's why I tell it.
We are not
Florian,
yet,
not to you.
you know, the standard is not yet written. The understanding of Munich meeting is now that it's a consistent one. So, okay. So now, if necessary means if the color space and or color characterization, which differs, then there is a need for the color conversion. There are no exceptions to this understanding. So third one is it's a conceptual shortcoming, which goes beyond just the standard issue, which is about the understanding of the term output device. And in today's implementations and also in some standard-related literature, you have the understanding that output device may be everything. It may be the display or the monitor or the proof printer where you happen to output some job, or the intended output device, which may be a printing press or printing process. So there's no difference between this. As a consequence, there is kind of a limitation, as this understanding does not reflect what we have to have in a professional production environment. So the chain is longer than what is possible having this kind of an understanding. So why is it limited? This is to understand this. We have, starting with transparency, you have the objects that undergo some transparency rendering, which is maybe the text element, a graphics element, and an image. And they have object color spaces, which means the image may be RGB, the gray area may be gray, and whatever. So the transparency blending space will be one consistent blending space, and there's a requirement that all the objects are converted which are not yet in this transparency blending space, that they have to be converted. And we have a third part, which is the output devices of the old understanding, which may be, as I said, all three of these devices. So we have two steps of the color conversion in that kind of an implementation, and I'm aware of, and you are aware of course, systems, high output systems, high volume output systems, for instance, that are only able to cover two steps. The one here, and then a second one taking the result of that blending and going to one kind of output device. But what we want to have is something a little different. Of course, the part here for transparency remains untouched, but what we would like to have is, and what we need is, that the first step is to convert to the color space of the intended output device. In this case, it happens to be, say, an offset process. And we want to, prior to say, okay, to the printer, now do the production job, we want to look at this on an actual, so-called actual output device, which may be the display of your computer or a proofing device. And this specific understanding, which comes from the daily production, needs now will be incorporated into the standard.
Come back for 1 second.
Yeah.
Right. So the other thing that's important about this is this also, this change also introduces some stuff that actually wasn't ever specified in the standard, although it was sort of implied, which is that it was how you went from 2 to 2.5. I guess it doesn't really have a number, but
What do you mean?
if going from transparency blending to output device,
Yep.
either what's now intended or what in the past was just output, what conversions and what process was used, especially with respect to rendering intents and other things, was never specified in 32,000.
Mm-hmm.
So one of the things that we're doing as part of this is we also define exactly what, where you get the rendering intents from, where you get the color spaces from. So there's all of the pieces of this model are now spelled out, or will be spelled out in the text, as agreed to in the Munich summit.
Yeah, that's right. Good. Another thing is, and this is the conceptual issue, if an implementation follows exactly the rules of the 32,000 understandings so far, as we had come to one understanding now for the issues I've talked about before, then we may face unexpected color conversions of device color values. What does that mean? A device color value may be black text, which is colored just by the ink black, and we want to have it consistent just black until the very end of the printing press. And if the sequence of how color is to be handled is followed by the rules, according to the rules, then there is a high risk that there occurs a color conversion, which makes that black text being colored by cyan, magenta, yellow, and black, which is not a good thing for printing presses, because you will have, for register issues, you may have unsharp text then. And so this part is to be looked at a little bit closer, because the thinking behind this is taking into account at least two basic rules. So the current rule caused that unexpected color conversion due to these two basic thinking. The device color has to be color characterized. So prior to a color conversion, I have to have a color characterization like an ICC profile, which is the typical color characterization, assigned to that device color. So there may not be just device black, it has to be some black. An ICC profile has to be assigned. So this is one thing, because this is a basic requirement for color conversions. The second thing is, as I said before, if that object is not in the same blending color space as the blending color space, then that color conversion has to take place. So how can this happen? The problem is the device colors that sit inside of such a transparency group, I will give you an example in a minute, not necessarily have that same blending color space. So where do they get it from? And this is the issue that causes the problem. There's that kind of a principle that it has to be followed. So each object, you may ask it, is it ICC based or calibrated? If yes, then you have that color characterization that is needed. If it's just a device color, like device cmyk or device gray, then there is the question whether there is an assigned default color space, which is also then ICC based. So again, no problem. You have then a clear color characterization. And if this one is not there, then it has to be some environment characterization, which may be the setting of the application or the printers in the printing system, the assigned profile, if you want, for that specific device color. So this is how one object in a PDF gets its color characterization that may be needed for a color conversion. So this is the basic thing. Now let's look at a simple example. And I'm very happy that at the time we had the summit in Munich, Leonard draw a lot of these things here. Like you remember, then we had discussions on things like that.
Walls were covered with.
We had large paper, and then we went through all the combinations. You may talk hours and hours of all the possible combinations, but this is one of the critical ones. Let's assume that we had an advertisement which is very beautiful. As you see, it's text with a green area on it, and it has some transparent effects. So this is a simple thing. And the environment in this case is ISO-coded. So it's an offset profile here in the European environment. So this describes the color characteristics of device values inside of this simple example. So the black text is as you would do it in a print appropriate way. It's just colored by 100% black and no cyan, no magenta, no yellow. So that's the advertisement as it sits and as it is created. Now let's look at it where the problem comes from. If that ad is placed on a magazine page. So this may or may not be a problem. In this case, we say, let's assume the ad is transferred to the US and the magazine has then not ISO-coded necessarily, maybe, but not necessarily is the color characterization of that magazine page. So in this case, let's assume it is swap. What happens then? The ad is placed on this page, and according to the inheritance rule that we have so far, the environment now for all device colors is that environment here. If there's no other provision, then it's swap in this case. Now you place the add here on the page and you can imagine what happens. In the case which is not unrealistic, that this add is placed as an isolated transparency group, and if, what is also not unrealistic, the previous color characterization, which is the ICC profile isocoated, is used to define the blending color space, then we have that case where a color transformation is needed. Why? We have the text, which is color characterized by swap. We have the blending space, which is isocoated. The rule applies that text has to be converted to this blending space. Then the blending takes place and the result goes somewhere. And this is not what people would like, because at the printer's end, no printer will like to have 72 something cyan, magenta, yellow plus the black ink. What they want to have is just plain black text as it was in the previous version when it was designed. So for that reason, and in these cases, not only occur if color management with RGB or so is needed. This would also happen for the cases where we are in daily production now, where people just want to work with process colors like cmyk. The case, as I showed it here, is a certain risk, and for that reason, we decided to change that inheritance, that rule how objects inherit their color characterization in a way that better suits this practical issue. And this means that, and this I think is one of the major changes in from the content. This will change the way device color is characterized. The new regulation will be as follows. There will be a new section in the standard describing the general inheritance rule. And then, whenever this section, whenever device color data is sitting in a PDF, and which has to be color characterized, then this section will be referenced. So there are several places in a PDF where this may be. This refers to color data, not just objects, which means, as I say here, it's on the one hand the page objects, like the images, the text, and the vector objects that may sit in a PDF, but also other parts that have color properties, like the blending color space. So why not having a blending color space which is DevicCMYK? So in all these cases, there's a need for color characterization, and color characterization, this is the second thing, typically is an ICC profile. So it may be a calibrated space as well, but usually it is an ICC profile that will be taken there. And the rule is then just to search for color characterizations which with identical numbers. That means if it's a device RGB, it has 3 colorants. If it's CMYK, it has 4, and so forth, and gray has 1 colorant. And then the rule is search for a color characterization, like an RGB profile or a CMYK profile, that can be used then as the color characterization. So where to find it? So there are different places, of course, and in order to avoid the problem that I just described to you with this advertisement example, that sequence is very important to have it in the right manner. And the agreed solution now is to start with that actual output space, which may be the default RGB as defined in the Adobe application, or some other pre-set setting of an application or an output system. Then if this is the only one, then the device color will get its color characterization from this setting. If there are others, these will win. And the first one would be an intended output space. So this one might be set like in Acrobat. If you check files and want to assign some simulation profile, this one would be taken. Or if you are, which is the professional version then of PDF in the PDFX PDFA area, then it would be the output intent if it matches. Yeah? In a PDFX environment in PDFA, it's then a must because other device color would not be allowed. So then in this case, the device color would be color characterized by the output intent profile. Then there may be another one that would overtake if there is a page group color space, then this one will be the defining one. Then there might be an enclosing isolate transparency groups blending color space. So maybe think of aggregation of several parts that go inside another part that are stored as a PDF, go into the next. So if these are isolated transparency groups and if they have their own color space, then the device will inherit its color space, its color characterization from there. And the last one would be the enclosing transparency group space for an object that sits inside that group. So this makes sure that, let's come back to that example we had before. We had as the blending space iso-coded. In the old days, it would have to inherit from here. In the new days, once that standard is in place, the device color would get its color characterization from the enclosing isolated group, and then it would be in the same space, no color conversion needed, and it would remain black text only. So this is the reason why this whole sequence is needed. This makes sure that undesired and unexpected color conversions, the risk of these conversions goes down. So. And then we had, this was not explicitly discussed, but I saw it when I browsed through the standard wording. Another issue was clarification needed for the definition of a specific color conversion from CMY to RGB, which is required in the case of a non-separable blend mode. These blend modes are calculated in an RGB-based color space. That means if you have a cmyk object that needs to be transferred to this blending calculation, there's a need to convert from cmyk to RGB. There's a special provision for black, but the CMY values have to undergo a specific color conversion. And in the standard, which was converted historically from the PDF reference of Adobe to the ISO wording, it simply says in the Adobe document, do this conversion in the usual way. This, of course, is not an ISO wording, because what is the usual way? For Adobe, it was clear. It was the Adobe usual color conversion, but it is not documented in the ISO part. So for that reason, there's simply the need to take the respective formula and put it into the standard. And this is a pretty simple one, because in this case, the color conversion is not ICC based. It's simply this kind of 1- rule, because black, which is also part of the basic calculation, is not subject here. So it's simply to get the red value that is needed, you take 1 minus the cyan, and then you get the red value, and so forth. So this simple thing should be incorporated into the standards so that everybody who's doing the implementation knows how to come from CMYK to RGB. Otherwise, some may feel like ICC-based color conversions are better. Let's do these ones. But then the basic numbers for the transparency rendering would be different, and the final result of that transparency effect would be visually completely different. So this, of course, is to be avoided. And by adding the simple formula to the standard, everybody will know how to implement this. So this was a simple one. The last one is one that we, for restricted time, so I think we came to the end of the afternoon meeting in Munich, was not discussed till the very end, is an issue with let's say a very specific case that in daily practice rarely will happen, but anyway it has to be, it should be addressed because there are cases where it's possible. And this issue is about the definition, the color characterization for device gray, and in a very specific situation, as you will see here. Because it's not in every case a problem, but in the case where device gray needs a color characterization, as it is a destination color space. So that means if some other element, some other color is to be converted to gray. And the issue is this is not a problem in the case where gray is the source color. In this case, at least in the PDFX or PDFA environment, the color characterization of device gray comes then from a cmyk profile. So it's just taking the black information, and the color characterization comes from the cmyk profile, which has to be there in a PDFX environment. But what happens if gray is the destination, so something to be converted to gray? Then we have a problem, because there is no way, if there is no gray profile in the file, to do the color conversion. Converting to cmyk would mean that gray becomes cmyk, which is not a good idea, as we saw with the text before. So we need a color profile to a kind of color characterization to make that color conversion possible. And as this was not yet discussed, we still have to do so. So this will be in the group talking about this will be a discussion. But I think it's not one possible option there is described on the next page, which is that we may choose to say that there is a need for an unambiguous description of how to convert, how to create such a gray profile that is needed, as we saw before, based on the black channel of a cmyk profile. So this, I would not be the right person to do this, but according to the others in the group discussing this topic, this seems to be not rocket science. So to create out of a pretty complex cmyk profile such a simple thing like the gray profile, and then work with this color characterization for device gray, and to which cmyk profile to choose. The rule may be just to follow the same sequence as one would have to find the cmyk profile for device cmyk. So this is a possible option. It has to be discussed. So this is implementation issues. That maybe there are some other issues, but I think this point can be resolved. And then all the open questions as far as the problems that occurred by testing the Altona and other practical files, these should be overcome by implementing the changes that we discussed so far. So that in brief was the talk about the issues we had so far and the resolutions. And it's pretty fast, and we have much time now to discuss. And in case you have any questions on this, but I assume that it's very, very specific. But in case you have any questions, please ask them now. And otherwise, I'd like to thank you for your attention. No questions? No big complaints from Leonard, which is good.
No.
The main issue is when and how the document for 32,000-2 will be written such that the advisory document for 32,000-1 can be issued, such that my committee can work on a PDFX document, such that we can get the confidence of people who've been very much scared off by this thing.
Leonard, you may help me. What time schedule did we have? I think it was fall to get the document ready.
Yep.
It's Andy to coordinate. So
So there's two documents. So Andy is working on the change to the chapter in 32,000 part 2, and I'm working on the separate document, which will be the guidance for part 1.
Mm-hmm.
And that's the document that will then that will be hopefully adopted by the PDFX committee for guidance on PDFX.
Yeah.
So the answer back to your question is, our next meeting is October in
Berlin meeting. Yeah.
Yeah. So everything will be ready before then.
Good.
Oh no, I'm sorry. Your October. TC 130 is October in Berlin. This is December in Florida.
This is why we have fall for the
Right, so we want to try to have it ready for the Berlin, even though it technically doesn't need to be ready till Florida.
Yeah.
That would be very nice if we had it for our Berlin meeting.
Right.
Thank you, Leonard.
Check some amount.
Okay.
Can I
Yeah.
ask you? Did you talk about the problem with around anti-aliasing and transparency? With our implementation of transparency, we did have some problems with anti-aliasing. Of course, even there remain some artifacts if you didn't apply the anti-aliasing in the right way at the right time during the transparency computing.
So it was not to answer the simple part of your question. No. So it was not a topic there. I can imagine. So the only case where I could imagine that there is a problem, but you probably have your examples for that, is once you have to render the edges of some object, and they have to be anti-aliased for some reason, and then of course there may be slight differences, but I'm not aware of any problem.
It was when you apply the anti-aliasing sooner than the final conversion, color conversion applies. Like if you do the computation as you apply transparency groups and things like that, then of course you can apply the anti-aliasing sooner before the transparency happens. Then you can get different results than if you apply it afterwards.
Yeah. Okay.
It's pretty obvious.
Anti-aliasing has to be done prior to your color conversion, because anti-aliasing is
affected
part of
by
rendering. It's a part of rendering.
Yeah, but it's intermediate steps. It's not the final thing. If you have groups, then you do something and then again calculate further with the result.
Even without the group, though, even just taking two objects, you still are going to do the anti-aliasing of each object, and then you're going to composite the two together.
Then it should be clear what happens.
So you have to do the anti-aliasing as part of the individual object, and then if you're doing any color conversions or whatever else you're going to apply.
But isn't anti-aliasing?
But the bottom line, it's not. But anti-aliasing is not part of the spec. It's out. It's not part of 32,000. It's out of scope. And
it's really an output issue to render something at the very end. So I would expect it to be at the very end.
Yeah, I would too.
Honestly,
it's a implementer's added value.
Yes, of course.
Out of scope, but you can't apply it. There's reasons why you can't apply it at the end. But anyway, it's out of scope of 32,000.
Yeah.
Same is true with APDFX.
Yes, correct.
Yeah, sure. Yeah. But you have a question as well, or a remark?
I don't have any remarks. It's way too technical for me. But I do have a question. I think I understand most of the issues that you raise, and even the solution to some extent. I think my question is, if you look at real-world scenarios, real-world files, how much difference is there going to be between rendering according to the new rules and what we see today? So for an actual end user, is this going to be something that is a major change from what we have today, or not?
Yeah, with regard to the cmyk, the inheritance rule, yes. Yeah. It really has big impact, because you never know how that PDF is created. The question of isolation, yes and no, switches on or off the blend space, but this is not done on the technical thinking that we have in mind here. It's done on some graphic design intent. So I want to have an isolated group because I want to ignore in my design what may come later underneath. So this is the reason why a designer switches on isolated group. Think of a logo. And as a side effect, because it's technical in that way implemented, we have that color issue. So things like that, which are beyond the scope of a designer, may impact the final rendering results and may confuse the people there. Because aggregation, taking pieces and placing them somewhere else in another environment as the first one, is really an issue. Some of the other things, like the device gray thing, are, say, a kind of a niche. They may occur. They're really, why not doing something with a black and white system? But I would agree if one says this is a kind of the exception. But not everything of this is such a niche or a specific thing. Yeah, they are basic things.
No, I agree with what you just said. I mean, the inheritance model is clearly the one possible place where renderings can and will change in that case.
And in a meaningful manner, you know.
Yeah.
And also, some of the broken rules where may have two reasons. One is maybe implementation things, so to have a kind of shortcut to be faster. This may be one reason, of course. Another is that breaking the rules sometimes better match the expectation of the user. So there were good reasons for doing so. Anyway, it's different implementation. It's different results depending on the vendor of a system, and this is why we have to remove it. And by this inheritance model, I think we would take a great step forward to meet both requirements, to have an unambiguous specification on the one hand, and to better match and meet the requirements of the end users.
One other thing though, before you, the one other thing where there's still a little, we still have to work some of the issues out on this. I mean, we still, philosophically, this is all done, but some of the details, there's some considerations around screen versus print, and it's specifically inks and ink handling, because as Florian pointed out, there's issues. You don't want to lose. You've got a single channel color, and you don't want to start polluting that single channel and the other channels. And there are cases where trying to be precise in following the rules in a print situation may lead to that not being the case. I mean, we're trying to make it never happen. And so we want to make sure that happens in all cases. And so we're just trying to continue to make sure we haven't missed anything, because some of the rules that made perfect sense on screen have been changed by print vendors previously, in current implementations, and we don't want to break printers just for cleaner rules. So that's one of the biggest concerns right now is obviously for print.
And there is another set of issues, and it's not directly related to PDF, but it falls in the same sort of category. And that is, for example, if one places content into an InDesign document, places PDF content, more specifically a PDF X4 file, let's say, that has a different output intent than the default output space of that particular document. Right now, the output intent is totally ignored by your design when you place that.
We want to get them to fix it, though.
I have that on a list of things, but
it's the kind of case that
we want to make sure that what we do there is consistent with what's going to happen here.
Yep.
Yeah. But again, it's a kind of what will be the expectation of the user? What happens if it's done properly? Then it should be handled as I showed it before. The output intent of that placed file should be.
My point is that in InDesign, officially you are not in a PDF environment at that point. Placing PDF into something that isn't PDF. But the thing is that we need to make sure that it is consistent.
Yes, right.
Or that if the user has an option of saying, I want something different, or I want something that's consistent.
On purpose, Right
now, the user just sort of gets whatever InDesign decides to do with it.
But it should be I totally agree. It has to be consistent. Because why telling somebody you're not allowed to aggregate PDFs in InDesign? So some may have their specific tools doing so. Others may just place it in an InDesign page to make their sheet for their web offset press or so. But it may be not the best idea.
InDesign isn't supposed to be an imposition tool.
I know.
But the fact is, whenever you place an add into an InDesign document, you're effectively doing that. So we have to make sure that that's consistent with all these rules here. And that's another reason why as soon as I have the wording for this, the better, because I have to get to the InDesign team.
But I would encourage you to at least allow then the user to switch on and off that output intent profile, becoming the new blending space.
I understand that, but the point is right now there are no options, and it's just
they're fully ignoring it. Yeah.
By the way, the same thing is true with if you place a PDF A file or anything that has an output intent. It's totally ignored.
So maybe one follow-up to that, and to conclude perhaps, because we're running out of time, but last session is a panel session anyway, so we can do whatever we want with that. Again, this is a very technical thing that you've been doing. When I think about a group like the Gantor group, where you have a bunch of end users around the table, is there any
What else?
thought about how this is going to be communicated? How are you going to explain to people that this might actually change something to the way their files are rendered in the end? As
I
in
think you just said it, this might actually change something about the way your files are written. I mean,
he has a very
David,
you're hired. No, he has a very good point. It's one thing to write it in ISOEs, it's another thing to write it in some sort of language that mere mortals can understand. And it may behoove all of us to somehow come up with something, a parallel document, which basically says, this is how this thing works, that people can really understand.
Yeah, you know, I prepared for, as this is a technical conference, so
Yes.
but
understand.
the other thing, I know what it means. I wouldn't place this, no, I know. I wouldn't go with this document and explain to my wife, she happens to be a designer, graphic designer. She browsed through the presentations and said, okay, you will make it. Now, of course, we wouldn't then have to have some more examples like the one I showed, and in even more practical manner, and explaining them. This is what it was before, and that's what it is in the future.
Agreement, but there's no action item for anyone
No.
to do that,
No.
and that's the problem.
So the Gantt work group is an excellent group to take that on. The PDF Association would be another alternative place to take that on. And I think David, you guys are right up there in both groups. Feel free to take it.
Copious
You are
spare
as well,
time,
right?
right?
I am indeed.
Copious spare time, right?
Okay,
So bring it up in Toronto.
I'm not there, but you are.
That's true.
so you will bring it up.
Drink Canada Dry.
Even more work that stacks up.
More work,
Yeah.
thanks.
Good.
Okay,
Okay.
Great.
thank you
Thank
very
you.
much.
Thank you.
It was very